Okay, good afternoon once again. Can you hear me, Madam Esther? Are you with me?
Yes, I think I'm with you.
All right. I was actually about to start since I wasn't seeing anybody online before you came on. I wanted to go on and then maybe
Okay.
recorded video. Okay, so I'm sure your day is going on fine. Your voice is cracking, maybe your network.
Yeah. And yours?
Yeah. We give God praise.
Yeah, I guess it's left.
Okay. Can you hear me now? Can you hear me?
Yes, I can hear you very well.
Okay. So quickly, we are looking at chemical combination, a very short, brief topic. Just run through it. There's nothing much there actually. So what we in this aspects of the topic, what is expected of us to teach the students in terms of objective is that they should be able to maybe define chemical bond or bonding, able to identify the type of bond that is present in a certain compound, and also they should be able to differentiate between maybe electrovalent compound and covalent compound, probably in terms of differences. Then also mention the type of, maybe identify the type of bond formed between two elements if given their electronic configuration of the respective elements. And so that's just the objective. And at the end of the day, the student should be able to answer questions on those areas. Then you will know that you have been able to achieve your stated objective for the class. Is that okay, madam?
Yeah. Yes, it is.
Okay. So maybe let's just have a little interaction as we got before we move on to this. Do you have any issue on this topic, or maybe is there any area when you think the students are struggling with before we dwell on the topic extensively?
On this topic?
Yes.
You mean on this topic?
Yes. Chemical bond is actually an SS1 topic. Maybe SS1 first.
Yeah.
Yeah. So you teach SS1 now or SS2?
Yes, I do.
Yeah, okay. So do you have is there any
In short,
particular?
teacher in my
Sorry? Seems
I think the only area I'm having issues with is when you are you hearing me?
yes, I can. Go on.
Can you hear me?
Yes, I can. I can.
Okay. I think the area when it comes to the types.
Okay.
When it comes to the types, I think that is the area I'm having issues with.
Okay, the types of bond present in the compound. Okay.
Mm.
Okay. Okay. So before this topic is taught to the student, it is expected that the student should know electronic configuration. And that's actually the build up to this topic. So I think maybe we should start from that aspect. Electronic configuration. Are you with me?
Yes.
Okay. So in terms of electronic configuration, electronic configuration of elements can be written in various forms. Either maybe you are using the S, P, D, and F notation, or you are using the K, L, N shell notation. And mostly like either we say excited state or in a ground state, and depending on it. So in most questions under chemical combination, the electronic configuration of the element are always written in the SPDF notation. So it is not left for the student to be able to identify the particular element in quotes. So if we are to go by the SPDF notation, the s orbital has a maximum of how many electrons? Can you hear me?
Let's look.
Can you hear me?
Yeah, I can see you.
Okay, the s orbital.
Yes, I can hear you now.
Okay, the s orbital has a maximum of 2 electrons. 2 electrons. That's maximum electron it can take. Why? Because it has only one subshell. The p has a maximum of 6 electrons, d 10 electrons, and f 14 electrons. So let the student know this first. That's the basis. Then, and if they've been able to identify the maximum number of electrons the various orbital can take, then what we begin to build on the electronic configuration, they will understand better. And then let them also know that the s orbital is taking a maximum of 2 electrons because it has only one subshell, which is represented by one rectangular box or one circular box. While the p orbital has 3 rectangular boxes all joined together. So 2, 4, 6. That's why I take a maximum of 6, because each of these boxes will take a maximum of 2 electrons. Then, if you do by simple mathematics, divide 10 by 2 should give me 5. So your d orbital has 5 rectangular boxes. 1, 2, 3, 4, 5. Then the f orbital will have how many rectangular boxes?
We have 7.
Yeah, 7 rectangular boxes, just like that. So that is for in terms of the electrons that the orbitals can take. Now let's now talk about how do we write the electronic configuration of the said element as the case may be. So let's do it this way. 1s. Can you see the board?
Yes.
Okay, so if we have 1s.
Yes, I can see it.
Okay, 2x. You can write this down to 7x, 3x, 4x, 5x, 6x, and 7x. Have you done that?
Yes.
Okay, remember we're saying SPDF. So after S, the next orbital is P, and your P should start from 2. So 2P down to 7P. That's how to write it. So we have 3P, 4P, 5P, 6P, and 7P. Are you with me? Are you there? Okay. So after the P, the next should be the next should be D, SPD. So the D starts from 3. 3D, 4D, 5D, and 6D. This one stopped at 6. It's not up to 7. The D stopped at 6. Then you now have 4F, 5F, and 6F. Is that taken?
Yes.
Okay. Now we're going to do a little calculation that I will take the first 2 steps and you build up the rest yourself. So what you do is just take a line and strike this like this. The 1x. The diagonal line across 2x. Have you done that?
Okay.
Then the third diagonal line will go through 2p and 3x.
Yes.
Then the next line will cut across where?
Then the 4s.
The next diagonal line will cut
right
across. The next diagonal line cuts across where? 3p and 4s.
P.
Then the next is 3d, 4p, 5x. Next.
Okay.
Next. And then it's just like that. Hope you understood that we were able to strike it out.
Yes, understand.
Okay, thank you very much. So let's go over it now. The first line cut across where?
1x.
So we'll
Right?
now write it out. 1x. The second one was 2x.
2s.
Then
Third one is 2p.
2p. 3s.
Yes.
3p.
Yes.
4x.
4s. And 3d.
Good.
4p.
Thank you.
5s.
Good. Thank you.
4d.
Yeah.
5p.
I'm going to put a dot, 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 and so on. That is continuation.
Yeah, okay.
Okay. So once the students can write it out like this, they can write the electronic configuration of any element. Bearing in mind the maximum each of these shells can take. That is why I started by identifying the maximum number of electrons each of the orbitals can take. So, for example, a student cannot write 1s, 2s, and go to 3s. No, it must follow this order.
Yeah, okay.
Any question?
No.
Okay.
I think I'm okay.
Let's take, for example, I want to write the electronic configuration of, let's say, fluorine. Fluorine, I'm sure, has atomic number of 9, right?
Yes.
Okay. So if the atomic number of fluorine is 9, using the SPDF notation, what will be the electronic configuration?
Of fluorine.
Yes, following this order, that is the SPDF. That will be 1s2.
Yes.
Are you there?
2s2.
Yes, 2s2.
Yeah.
2p.
And 2p2.
Okay,
2p.
let's do something now. I purposely pause there. Remember, the p has a maximum of 5.
2p.
Of 6, rather. P has a maximum of 6.
Yes.
So let's do 2 plus 2.
4.
Take away that 4 from 9. How many?
It's 2p5.
So 2p5. Is that okay?
Yes.
Okay. Now, a student can write it as this, or you can write it using the 2,7 electronic configuration. That is your KLN shell notation. Are you with me, madam?
Yes, I'm with you.
Okay. So if we do it using 2,7, that means fluorine belongs to group what in the periodic table?
That means it belongs to group 7.
Okay, thank you. It belongs to group 7, period 2. Because of this last number here. So, which is the valence number of electron. That is group 7. Let's look at another example. Let's say, for example, I have sodium with 11 electrons. That will be what? 1s2.
I mean 1s2.
2s2.
2s2.
Yes. 2p.
2p6.
Thank you.
6.
Yes.
6.
Yes. Thank you.
And we go back to 3s1.
Thank you. That's perfect. 3s1. Or 281.
1.
Is that okay?
Yes.
Okay. Then let me write another one. Which element is this, madam? Can you try? Which element has this electronic configuration I just looked at now?
Silicon.
Silicon. Is this what I wrote? Is it correct? Look at it very well. I purposely did it so that
it's not correct.
Okay, so that when a student write this, you should be able to tell the student what they are writing is wrong. Yeah.
It's not correct.
Okay, what is
Yes.
wrong? What is wrong?
You're supposed to you're supposed to use 3P first before going to 4S.
Thank you. So that is wrong. So I did this on not that I did it purposely so that you will all be on the same page. So let's now have 3P6 4S2. Which element is this?
So this
You can what is also in this situation is let the student
is calcium. Calcium.
Okay, calcium. The student might answer, you get calcium. Tell them, add up the numbers up, which is the subscript, and
on
top. And then since it's 20, calcium is number 20 in the first 20 elements. Then if we combine, that will give you 2, 8, 8, 2. I think quite understandable. Is that okay?
Yes.
Okay. Which element has this? 1s2, 2s2, 2p3.
It's fluorine. Sorry.
That's
Sorry, I was looking at that your P. The two is not there.
Okay, 1s2, 2s2, 2p3. 2p3.
That is nitrogen.
Okay, nitrogen. Because it has 7 electrons, which is 2,5.
Yes.
I want to do that one again. Oxygen. What will be the electronic configuration?
1s2,
2s2,
1s2, 2s2,
S,
2p4.
Okay. Now again, because we are still on this a little bit, let the student know again the number of unpaired electrons and paired electrons. Like in the case of fluorine now, this P, which is the last one, 2p, 5, supposed to be 2p what? Are you there with me? Can you hear me?
Yes, I can hear you. The network is shaking.
Okay. I'll ask a question. I said, let the student know how to identify number of unpaired electrons. Like, for example, fluorine now, as the last number here is 2p5. The maximum this P can take is 6. So if you take away 5 from 6, I'm left with 1. So that means it has 1 unpaired electron.
Okay.
That's it. Like sodium now has 1 unpaired. This one
electron.
Calcium is 0. They are all paired. That is the last 2. This S shell is already filled up. It has no. Then nitrogen has how many unpaired?
1 unpaired.
No. Right. S2, 2s2, 2p3. So it has 3 unpaired electrons.
Okay.
Why is that so? If your P has 3 blocks. In teaching this thing, there's what we call rules. There's what we call the Halbach rule, Hund's rule, and the Pauli's exclusion principle. We're not looking at that today, but let the student know that in filling these things, one of the rules is that you put one first. That is 1 arrow first, goes around first, before you now begin to fill it up. So if you look at the case of nitrogen now, 1, 1, 1. This one does not have a partner. It does not have a partner, and it also does not have a partner. So it has 3 unpaired.
Okay.
So that's why. Let the student don't go and do it like this. It will be wrong. Even though if I count my arrow now, 1, 2, 3, 3. This is wrong filling. It's supposed to be 1, 1, 1 first before I come back and fill it up.
Okay.
I think that's that. So for the case of oxygen, this there's no space. I wanted us to do one. Neon has 10 electrons. What will be the electronic configuration for neon?
Be 1s2, 2s2, 2p4.
Are you sure?
Sorry, 2p6. 2p6.
Okay. Or using your KL shell to be 2, 8.
8.
Okay. Now, the basis of chemical combination is that all elements or atoms try as much as possible to envy those elements in group 8 or group 0, which have a stable duplet or octet configuration. That means their outermost shell is already filled up. Like in the case of neon, like in the case of helium. Helium is the first member of the group 0 element. It has just 2 electrons, which goes to the K shell, so it's already filled up. Helium, neon, I think we should also have the 18th element, your first 20 elements is also another member of the group 8 elements. Are you with me?
Yeah.
Your network is cracking, or is it mine? Like your voice is cracking. So let's. Can you hear me now?
Yes, I can hear you.
Okay. So like I was saying, we said every element try as much as possible to want to have a stable octet or duplet configuration. Let the student know the word octet means 8. That means the outermost shell is filled 8. Or duplet. Duplet means 2, which is in the case of helium. So on the board now, I have chlorine, sodium, calcium, nitrogen, oxygen, right? Now, these elements are just some few of the elements that we have. Remember the last time we said we have over 114 elements. So these few elements on the board want to look like neon in terms of their configuration, which has 2 8s. That is, the outermost shell is already filled up. So they attain that octet stability or the outermost shell being filled up either by losing electron or by gaining electron or by sharing electrons, which is the basis of chemical combination. Is that taken? Are you with me, madam?
Yes, I'm with you.
Okay. So, like I was saying, now, by definition, chemical combination, maybe if you want to write it out, right? By definition, chemical combination is defined as the attractive forces. Chemical combination is defined as the attractive forces, which holds the various chemical constituents together in different chemical species. It is defined as the attractive forces, which holds the various chemical constituents. The constituents in this case could be atoms, could be ions, together in different chemical species. Any question?
Sorry, can you come back again?
Okay. It is
Please,
defined.
can you give me the definition?
Okay. Are you ready now? It is defined as the attractive forces.
Yes.
It is defined as the attractive forces which holds the various chemical constituents. Which holds the various chemical constituents, in brackets, atoms or ions. Those are the constituents. Together in different chemical species. That's it now. Did you get it?
Yes, I got it.
Okay. So chemical combination or chemical bond is divided into 2 broad categories. Strong and weak. Is that again? Well, let me use the word chemical bond.
Okay.
So chemical bond is divided into strong bonds and weak bonds.
Okay.
Under the strong bonds, it is divided into 4 categories. We have ionic, we have covalent, we have dative, and then metallic. While in the case of weak, it's divided into two. We have van der Waals forces. And we have hydrogen bond. If you can't see the board, maybe you can hear my voice. It might help better. So we have strong bond and weak bond. Under the strong bond, we have ionic, covalent, dative. This dative can also be called coordinate covalent. You see it in some textbook. Coordinate covalent is also the same thing. Then we have metallic. Then under the weak bond, we have van der Waals forces and hydrogen bond. So for the sake of time, we'll just run through them and see how far we can go today. We are not going into more detail. What we'll just do is let the students know how to identify the type of bond that are present, since that's the major issue now. And then examples of the various bonds and how it comes about in terms of definition as well.
Yeah.
Can I clean?
Yes.
Okay. So we'll treat the first one quickly, ionic bond. Let me have this. Ionic bond. Either you call it ionic or you call it electrovalent bond. It's also correct. So
okay.
For sodium, what is the electronic configuration? 281.
Okay.
For chlorine, 287. Or I can say 1s2, 2s2, 2p6, 3s1 for this. But I don't want to go to that. You can also use that configuration as well and do the same thing for chlorine. Are you with me?
Yes.
Okay. So remember, we said the basis of chemical combination is to attain a stable octet or duplex configuration. So if sodium now want to attain a stable octet configuration, what do you think will happen to sodium? In other words,
stable. Okay. That means it has to give out.
Good. It has to give out its valence electron. While chlorine, on the other hand, has to receive valence electron. Some person might begin to wonder, why is it receiving or why is it giving out? Sodium has one valence electron, which is just this last one you're seeing here. It needs 7 more electrons to be stable, or it gives out this one. It is wiser and safer for sodium to give out this one and just become 2,8. Rather than going to look for 7. While chlorine, on the other hand, will not want to give out this 7. Rather, we hold on to this 7 and look for 1 more to be stable. So in a situation like that, that is what results what we call ionic combination. Ionic combination is a type of combination that arises when an element, usually metals, give out its valence electron to non-metals. Or sometimes we tell you that it is a combination that involves the transfer of valence electron, transfer in quotes, usually from metals to non-metals. Is that okay?
Yes.
Okay. And in most cases, how do you identify metals? Metals are those group of elements that are found in group 1, 2, and 3 of the periodic table. They are metals. That means their valence electron is 1, like in the case of sodium. I can also have 282, which is also a metal. I can have 283, it's also a metal. Or 22, 23. Anyone that ends with 2, 1, or 3 are metals. Is that taken?
Yes.
Why non-metals are found in group 5, 6, and 7. Like I can have 286 is a non-metal. 285 is a non-metal as well. But let the students also know that even though group 1, 2, and 3 are metals, we have strong metals, and the strong metals are found in group 1. While the strong non-metals are found in group 7. Take it.
The last sentence.
Okay. We say metals are found in group 1, 2, and 3 of the periodic table. While non-metals are found in group 6 or 7, 6, and 5. Group 5, 6, and 7 of the periodic table are non-metals. Then in terms of metals and non-metals, we have the strong metals and the strong non-metals. The strongest of the non-metals are found in group 7. That in terms of non-metals. While the strongest of the metals are found in group 1. Is that taken?
Yes.
Okay.
Yes, it's taken.
So we have just less than 10 minutes to shut down. So once it goes off, we'll come back immediately, unlike the usual 10 minutes. So just in case it goes off. So coming back now, yesterday on Monday, Chemist Obie said something about atoms, that when they lose electron or when they gain electron. So in the case of sodium, this is what I'm going to call now, is called before combination. This is before combination. And this is then after combination. So this is the electronic configuration before combination for sodium and chlorine. Then after combination, I should be adding 2, 8. Remember, the 1 is already gone. So it will now become Na, but with a positive sign.
Yes.
Telling me that it has given out its electron. Then chlorine, on the other hand, become 2, 8, 8 with a negative sign, telling me that it has accepted electron.
Okay.
So this is a transfer of electron from metals to non-metals. So what I'm trying to talk about now is, in case you are teaching the student, these are examples of ionic compounds, like in the case of sodium chloride. This is what I'm doing now, sodium chloride. So then again, let's look at something. If you see now, sodium has 1 plus, chlorine has 1 negative sign. Opposite charges attract. So as a result of the ions which is formed here, this will result to the force which will now hold them together. So the formula now becomes NaCl. So it is the charges or the ion that is formed, holds the atoms together, and then it forms the compound, which is sodium chloride. Is that taken?
Okay.
Any question?
Yes.
Okay.
No.
Then moving on. So I wanted to say something now, just skip me now. I hope I remember if I move on. Anyway. So that is that about the combination before and after combination. So I don't need to draw the electronic configuration. I'm supposed to draw the shells. Draw 3 shells, 2 shells like that, but because of time, I will be drawing that so that, but I believe when teaching the student, you can draw the orbital diagrams. Let them know how the electron is being transferred. Yeah? So that is that.
Okay.
Okay, so again, we can also look at another example, formation of calcium chloride. It's also another example of ionic compound, calcium chloride. Can you give me the formula for calcium chloride? I think we did that yesterday. Calcium chloride, that'll be on Monday, formula of compound.
Okay, CaCl2.
Okay, calcium chloride. Now I remember what I wanted to say about that sodium chloride. Remember, Na is a metal, right?
Yes.
Chlorine is a non-metal.
Yes.
When writing the formula of a compound that is formed from ionic combination, the metal should be written first before the non-metal. That is why it is NaCl. So, any question now? Are you with me?
No.
Okay, so let's move on now.
Yes, I'm with you.
Okay, calcium has 20 electrons. That is 2, 8, 8, 2. Chlorine, on the other hand, has 17. 2, 8, 7.
So, okay.
So this is before combination now. So calcium will give out its 2 valence electron to chlorine, right?
Yes.
And 2 plus 7 will give us 9, which is not
9.
possible. Maximum is supposed to be 8. Meaning that I will need another chlorine again. I will need another chlorine again. So that one come here and another one comes here. So that is 2 chlorine will combine with 1 calcium.
Oh. Okay.
So at the end of the day, the formula becomes CaCl2.
2.
That's another way why the formula is CaCl2, telling me that 2 chlorine has combined with 1 calcium.
Okay.
So at the end of the day, again, this Ca becomes, that is after combination, becomes Ca2 plus. Chlorine will be Cl minus with another Cl minus. So a total charge on chlorine will be 2 minus. The total charge on calcium is 2. So since the charges are equal, it results in the force, attractive force that binds the atoms together. Is that okay? Any question?
No, sir.
Okay. Let me look for one question I saw here from WAEC. I think I used to see questions like that, a lot of them. Let me just see. Okay. Okay, so now you said something that I think I'm trying to remember. I think it was in NECO I saw that question this year, where they were asked to identify the type of bond present in a certain compound, and they give them examples of compounds. So if, for example, I have NaCl, CaCl2, NH3, NH4. Are you with me? How many minutes do I have more? 2 minutes. Quickly, let me just identify this one more. Can you hear me?
Yes, I can hear you.
Okay, so for this NaCl, what type of bond is present?
Ionic bond.
Okay, ionic bond or electrovalent. CaCl2.
Yeah. Ionic bond.
Okay. NH3.
That is the one I don't know because you have not taught me.
Okay. I love that response. Okay, let's do it together. Nitrogen has how many electrons?
That's 1.
No, nitrogen. N.
Okay.
That's 2, 5.
That yes.
Hydrogen is 3 here. That means I have 1 H, and another H, which is just 1, 1, 1. Are you with me?
Yes.
Okay. Now this sodium needs 3 more electrons. It will not give out this 5.
Okay.
Hydrogen, on this other hand, each of them need 1, 1. It will not also give out the one that is already asked. You want to buy something of 100 naira, you have 50 naira. You will not give out that 50 naira till you get 50 naira to balance it.
Yes.
So what we have here is this. Nitrogen and hydrogen will say, guy, come together. Bring your own, I bring my own. Let us put our heads together and we'll form a bond, which is called covalent bond.
Okay. Okay.
So in this case, if you add 1, 2, 3 plus this 5, it gives me 8. So then if you draw the structure, you will see it like this. I'm running out of time. If you come, we'll come back and finish it up. This 1, 2, 3, 4, and 5. This is the structure for the nitrogen. Then each of these hydrogen will come here, and come here. Like this, like this, like this. So if you look at this now, H is looking as if it has 2, which is complete. This is also complete. This is also complete. And the nitrogen is also complete. So at the end of the day, everybody is happy.
Okay.
So there's something here in terms of covalent bond. This one now, is there anything sharing with these 2 dots I draw here?